Section 21.3 Nuclear Transmutations. Thus far we have examined nuclear radiation reactions in which nucleus spontaneously decays. A nucleus can also change identity if it's struck by a neutron or by another nucleus. Nuclear reactions that are induced in this way are known as nuclear transmutations. In 1919, Ernest Rutherford performed the first conversion of one nucleus into another. He succeeded and converted nitrogen-14 into oxygen-17 plus a proton using a high-velocity alpha particles emitted by radium. The reaction is nitrogen-14 plus helium-4 yields oxygen-17 plus hydrogen. This reaction demonstrated that striking nuclei with particles, such as an alpha particle, could induce nuclear reactions. Such reactions made it possible to synthesize hundreds of radioactives in the laboratory. Nuclear transmutations are sometimes represented by listing in order the target nucleus, the bombarding particle, the ejected particle, and the product nucleus. Written in this fashion, equation 21.8 is: the alpha particle, proton, and neutron are abbreviated as A, P, and N respectively. Accelerating charged particles. Charged particles such as alpha particles must be moving very fast to overcome the electrostatic repulsion between them and the target nucleus. The higher the nuclear charge on either the projectile or the target, the faster the projectile must be moving to bring about a nuclear reaction. Many methods have been devised to accelerate charged particles using strong magnetic and electrostatic fields. These particle accelerators, properly called atom smashers, bear such names as Cyclotron and Synchrotron. The cyclotron is illustrated in Figure 26. The hollow D-shaped electrodes are called Ds, and the projected particles are introduced into a vacuum chamber within the cyclotron. The particles are then accelerated by making the Ds alternately positive and negatively charged. Magnets placed above and below the Ds keep the particles moving in a spiral path until they're finally deflected out of the cyclotron and emerge to strike the target substance. Particle accelerators are used to synthesize heavy elements, to investigate the fundamental structure of matter, and to ultimately answer the questions about the beginning of the universe. Figure 21.7 shows an aerial view of the Council Européen pour la Recherche Nucléaire, the European Organization for Nuclear Research, near Geneva. Using neutrons. Most synthetic isotopes used in medicine and scientific research are made using neutrons as projectiles. Because neutrons are neutral, they're not repelled by the nucleus. Consequently, they don't need to be accelerated as do charged particles to cause nuclear reactions. The necessary neutrons are produced by the reactions that occur in nuclear reactors. For example, cobalt-60, used in radiation therapy for cancer, is produced by neutron capture. Iron is placed in a nuclear reactor where neutrons bombard it. The following subsequent reactions take place. Transuranium elements. Artificial transmutations have been used to produce the elements with atomic numbers above 92. These elements are known as transuranium elements because they occur immediately following uranium in the periodic table. Elements 93 and 94 were discovered in 1940. They're produced by bombarding uranium-238 with neutrons. Elements with still larger atomic numbers, usually normed by quantities of particle accelerators. Curium-242, for example, is formed when plutonium-239 is struck with an accelerated alpha particle. In 1994, a team of European scientists synthesized element 111 by bombarding bismuth target for several days with a beam of nickel atoms. Amazingly, their discovery was based upon the detection that only 3 atoms of a new element. The nuclei are very short-lived and they undergo alpha decay within milliseconds after synthesis. In 2004, scientists reported the synthesis of elements 113 and 15. As of this writing, the result is yet to be confirmed, although they look promising. Evidence for element 118 was reported in 2006. Elements and symbols have not yet been chosen for these new elements.